We're all familiar with rush hour gridlock on the road. Well, it happens at airports too. If you look at any major metropolitan airport, such as Los Angeles International, at 5 p.m. on a Friday evening, the number of airplanes wanting to land all at the same time can boggle your mind. As you might imagine, making room for all those arriving airplanes is a demanding task. But with a few unique techniques and today's modern radar, ATC does a very nice job of it. So let's talk about how ATC's use of these techniques not only expedites traffic into major hubs, but lets us GA types get on the ground quicker too. One easy and quick way to increase approach capacity is to have all the airplanes make an approach to one runway and then have some of them sidestep over to land on a parallel runway. As you can see, San Jose has 3 parallel runways, but only the middle one has an ILS approach. If the ceiling is high enough, ATC just bunches airplanes up on the localizer and tells them to plan on sidestepping to a particular runway. You're expected to start that sidestep maneuver as soon as you see the runway environment. Now, since the controller and the pilot don't have to worry about the preceding airplane dawdling on the principal runway, ATC can significantly cut down the interval between airplanes on the approach. Checking out the minimums table, you can see that the sidestep minimums are higher than the straight-in minimums, but they're still lower than a lot of non-precision approach minimums. Sidestep minimums are fairly common when an airport has parallel runways, but only one ILS approach. On the other hand, airports like Raleigh-Durham here that have parallel runways with ILS approaches to both runways give ATC a much better opportunity to clear the air, so to speak. Depending on the space between the runways and the sophistication of the radar available, they can use several different procedures to speed things along. The simplest procedure is called parallel ILS approaches. If the distance between the runways is 2,500 feet or more, ATC will direct airplanes to both runways in an alternating pattern. The controller must stagger the airplanes on the approach to maintain a specified diagonal distance between them. The minimum distance is either 1.5 miles or 2 miles, depending on how far apart the runways are. When parallel ILS approaches are in progress, either the ATIS or the controller, or both, will tell you so. Why does that matter to you? Because, as you might expect, when parallel ILS approaches are in progress, it is especially important for you to maintain any airspeed the controller assigns you so that you maintain the correct spacing on the approach. It's also particularly important to fly the center line of the localizer so you don't crowd airplanes on the other localizer. Now, if the distance between the runways is greater, between 4,300 feet and 9,000 feet, as is the case here at Kansas City, ATC can speed things up even more. They can use a procedure called simultaneous parallel ILS approaches. Notice, down at the bottom of the ILS runway 19 right approach chart, there's a note that says simultaneous approach authorized with ILS runway 19 left. Now, along with the additional room between the runways, ATC must have a radar controller monitoring the final approach course. In this case, airplanes can be flying their respective localizers virtually wingtip to wingtip. The final monitor controller's job is to ensure that no one drifts into the no transgression zone between the localizers. The final monitor controller and the tower controller both transmit on the tower frequency, but the monitor's transmissions will override the tower's. That way the monitor can immediately order a pull-up or a left or a right breakout vector in the event of a serious transgression. Again, if simultaneous parallel ILS approaches are in use, the ATIS and/or the controller will tell you so. Now, because you can be flying almost wingtip to wingtip with another airplane in the clouds, if you're going to use this procedure, you should feel very comfortable with your skill level and your proficiency. If you're not comfortable with the procedure for any reason, turn it down. That's your privilege as pilot in command. Well, what if a pair of runways does not have at least 4,300 feet between them? Are you stuck with just the staggered parallel approach? Nope. Science and technology step in to save the day, as they did here at Minneapolis-St. Paul for runways 12 right and 12 left. This procedure goes by the mouth-challenging name of simultaneous close parallel ILS PRM approach. The PRM part stands for Precision Runway Monitor, and this is one smart, efficient radar. Since the runways are closer together, it follows that the no transgression zone is narrower and problems must be identified and acted on sooner. The radar does its part by updating itself very frequently. Then its associated computer projects where each airplane's ground speed and track will take it in the next 10 seconds. Each runway has its own tower controller and final approach monitor. And each runway controller team has two communications frequencies called the primary and the monitor frequencies, and they're for their exclusive use on that runway. For instance, on the ILS PRM runway 12 left approach, the primary frequency, the tower frequency, is 123.905, and the monitor frequency, labeled PRM, is 132.525. Now, pilots are only allowed to transmit on the primary frequency, but they have to listen to both frequencies. That way, if someone's talking when he should be listening, or someone has a stuck mic switch, the pilots will still be able to hear breakout instructions immediately. Now, the approach chart has some big notes to remind you about listening on the second frequency. In the plan view, it says dual VHF communications required, and down at the bottom of the chart is a small print note that says Monitor PRM Controller. Now notice, there's a second note at the bottom of the chart that tells you that there's an adjacent page of information on how to fly this procedure. And when you look at that page, there's a whole list of requirements you need to meet to fly a simultaneous close parallel ILS approach. Now, ATC has another tool in their bag of tricks to expedite traffic, although this one is rarely used anymore. ATC can stack airplanes in a holding pattern over a fix at 1,000-foot intervals and then peel them off the bottom to start an instrument approach at a specific time. This is referred to as timed approaches from a holding fix. ATC can use this procedure to minimize delays when there are numerous aircraft waiting for an approach. Think of it like a metering light on a freeway on-ramp. The controller is telling the pilot to be at the line and ready to move when the light turns green, so that no time is wasted. Now, obviously, the airplane can't just pull up to the line and wait. The pilot has to do some planning and adjusting of his holding pattern to move into position as close as possible to his starting time. Just like on the freeway on-ramp, traffic will move most efficiently if everybody is rolling up to the line just as the light goes green. Although the controller will not specifically state that timed approaches are in progress, the assigning of a time to depart a final approach fix or outer marker inbound does indicate that ATC is using timed approaches. Now, there are certain criteria that must be met for timed approaches to be used. First, there must be an operating control tower at the airport where the approaches are being conducted. Second, the missed approach procedure cannot have a course reversal. You don't want airplanes flying back out the final approach course and meeting the next inbound airplane head-on. Third, if there is only one missed approach procedure available for that approach, the weather must be equal to or greater than the circling minimums. As you can see, ATC has a lot of tools in its bag to keep up with the ever-increasing demand on our airports. And when ATC uses these tools, it helps you and me get where we're going as planned on time.